Hi, Graham. Thanks for your email. I've got a couple of the questions here that you referred to, and I'll hopefully try to get you started. The other thing I'll say to you right off the bat, because I might forget later, is as far as the appointments go, I start at 4 and everything is booked until 6, I believe. I'll double check that while I'm talking to you here. Hang on a minute. Yes, I am booked until 6. So you have the 5 to 5:30, and I have blocked off the 6 to 6:30 appointment. And so if you don't mind sort of doing a half hour and then going to get a coffee and coming back half hour later, I can do another half hour with you at that point, but that's kind of the best I can offer right now with the way the schedule looks for Thursday. I shouldn't be booking an hour appointment for you, but we can do that certainly for the first week anyway, and go from there. The other weeks, it'll have to kind of be a luck of the draw. If I don't have appointments after someone's appointment, then I always let them stay longer, as long as they need to. So if it works out that way, then certainly we can do longer appointments, but we can't book it in there like that because the system won't let me show 2 appointments in 1 week for you. So anyway, let's get back to our derivatives here. And so the one that you were asking me about, you were mentioning, and you're right, that we have a product rule on the top in the numerator here. And then we have a quotient rule because we're also dividing by the function 3x plus 7. So you're right that you have to apply both rules. And the rule that you should use when you're doing that is that you should do the multiplication first and then the quotient rule. You really can't do the quotient rule with the way it's written. It would just be impossible. And so what I would recommend, because both of these binomials are just degree 1, meaning that they only have an exponent of 1 on the x, is that I would first multiply the 5x minus 3 times the 2x plus 7. So what I would do is I would get my original function to look like this, 10x squared, and then you would have 35x minus 6x, so that's going to be plus 29x, and then minus 21. And then on the bottom, you've got 3x plus 7. So now I would say that you're ready to do the quotient rule. So by taking the product there, you haven't had to use the product rule, so it hasn't made your derivative any more complicated than it would be just like a normal quotient rule derivative. That's the easiest way out of this one for sure. If these were more complicated, and I think in this course you're in 1005, I don't think that you're going to see anything more complicated in your numerator that you can't multiply out and make into a polynomial. So I would say do that first, just multiply it out, and then really you just have one function on top and one on the bottom, and when you find your derivative, you're going to take the derivative of the top, and you're going to multiply that by the bottom. Then you're going to subtract the derivative of the bottom, multiplied by the top. And then that whole thing goes over 3x plus 7 squared. So it's all over but the simplifying, and I'm not sure exactly how much simplifying you're required to do in your course, but if you were to multiply out these binomials using FOIL, then we would have 60x squared, 140x plus 63x, so that'll give us plus 203x. Then we're going to have 29 times, oh, sorry, I read that as a 21, my mistake. Sorry about that. So backing up a little bit, we have 20x times 3x is 60x squared. Then we have 20 times 7, which okay, so I didn't bother finishing off the first example there just to keep the video a little bit shorter. But here we are with the second question that you brought up, and I will apologize. I do not have a copy of the text for your course, so I don't have the sections that you sent me, but I can see that you're quite frustrated with it. If you wanted to do a cell phone picture of any of the questions in those sections that are giving you trouble, I'd be glad to go through those with you on the video as well, and then that might help us when we do meet to sort of focus on what we need to cover. So your question in number 2 is in regards to the E functions, and you're right, we're kind of contradicting a little bit here, so I'll correct that description a little bit here. E is not a variable. E is a constant, and so we use it just like pi. If you think about pi, everybody knows pi is a irrational number, 3.14, da 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 da, it goes on forever and ever, right? And E is the same thing. E is approximately 2.718, and it's also like pi, where it never repeats and it never stops. It just keeps going on more and more decimal places. So E is a constant. E is not a variable, just like pi is a constant and pi is not a variable. So E is not differentiable. It would have a derivative of 0, just like any other number. When E gets involved in derivatives, it's when E is a base, usually for an exponential like this, that we're asked to differentiate. And then that's when things get a little interesting, because it has its own set of rules for taking the derivative, okay? So basically the rule for taking the derivative of y equals e to the exponent x is that the derivative itself is exactly the same as the original function. The only time that that wouldn't be true would be if we started off with, say, e to the 3x or something like that. If I'm taking the derivative of that, we would start by rewriting the original function. But then there's a chain rule, because the 3x is its own function and it has a derivative of 3. So when we simplify this, we end up with 3e to the 3x for our derivative. So that's how taking the derivative of an e works. It takes just a little bit of practice, and it does look a lot different than the ones you're normally used to doing. But that's what they're trying to explain when they're talking about the e values, and they're asking you to take the derivative of them. Okay? So if you have questions that are specific, the easiest way is for you to just take a cell phone picture and send me the JPEG by email, and then I can go through some specific examples for you. I'd be happy to do that, and I think the more you see and the more you practice, the easier it will become, because they all follow certain patterns, and once you get used to them, they're not as bad as they seem right now. I know it's a lot to take in. It's a whole new level or a whole new sort of branch of math, and it can be really confusing, but I'm sure I can help you make sense of it all. Okay, I hope that helps.